suppose you had some DDL that you wish was a non-blocking DDL, but sadly isn't, because say you were on an earlier version. How do you handle that? You can handle it in a typical case of how modern applications behave without too much fuss. The kind of starting assumption is most vividly quite a plausible assumption is when you're in a hard shell situation. The assumption is you'll never have pending DML whose duration is more than a couple of seconds, let's say. Because, after all, pending DML is when you change stuff in tables, and at least in the hard shell scheme, you never change tables as a response to an end user stimulus, except you change all the things that you want to change in one server call and then commit. Worst case, something went wrong and you rolled back, but you've done one or the other, right? You're never into a server call, out, and leaving pending DML, right? That's another reason that makes the hard shell philosophy so compellingly attractive. If you're in the bag of tables world, you'll be in, out, in, out, in, out, leaving pending DML until the final in to commit and out, or in to rollback and out. It's all a very risky proposition in itself. But let's assume that all this is happening in response to one end user activity at the UI, which results in a connection checkout, blah, 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 and a connection release. In this kind of bag of tables world, then, because you're in this connection pooling situation, the duration of pending DML will be pretty short-lived. It'll be short to the duration that you can typically wave your hands and brush away as just network trouble, you know. The hotel network isn't behaving very well. You had a 10-second glitch. I'm sorry, don't worry about it. These things happen, yes. So in that regime, I'm sure you can see what you do. You just set the DDL lock timeout to the maximum value you can get away with, yes, which could even be 10 seconds, and hope that no pending DML will have a duration greater than 10 seconds, and under those circumstances, you're bound to be okay, okay? And if you want to do just one extra little level of something to increase the chances of success, all you need to do is have a loop around the attempt. So you have a little sleep, you know, pick a number, I don't care, 20 seconds, a minute, I don't care. And then you, having woken up after the sleep, you do the alter table in the little begin-end block with execute immediate, and your exception handler catches the error in question and increments a counter. So that if you were to wait more than 10 seconds and get the error, you just note, oh dear, I got that error, blast, I didn't succeed, n gets n plus 1, right? And then, or indeed not n gets n plus 1 at all, you just do it, but the n gets n plus 1 is useful for the eventual error you type out. What you do then is have a big master timeout on the outside, and if you say, if I didn't get my thing done over however many iterations I managed to do in an hour, then I'm going to say this is just too hopeless. And then you would say, you know, I did 76 attempts and I still didn't succeed, right? Under those circumstances, the administrator behind the scenes would have no choice but to investigate in VDOL on a session and kill a few things brutally, right? Because maybe there's some old-style rogue batch program that was written in such a way that it had half-hour pending DMLs and so on, and you just have to kill it. But don't forget, if that was the case, you'd have noticed that that was the case in testing, and you'd have to have a slightly more troublesome regime around, I hate it when an alert pops up about the latest mad thing that Trump has done. Cut that out. Lost my thread altogether. You'll cut that out of the recording, won't you? Where was I now? You'll just have to have a more cumbersome human process around the thing. You know, stop these batch jobs, do the exercise, and restart them. And generally speaking, these batch jobs have that character that you can suspend them for a period and then restart them, and everything is okay. Okay, still with that? So that was that story of blocking and non-blocking DDLs, and I was trying to make the point that if you have to contend with old-style blocking DDLs, you can use this DDL lock timeout to reasonable advantage. And now just one little piece of sad news, that is that while EBR, all the mechanisms I've explained, are unrestrictedly available in even XE, if you wanted it, but certainly in standard edition, as it happens, some of these non-blocking DDLs are set up, factored as we call it, to be enterprise edition only. Not my choice, but it's the case. Now, these Move It guys were a born in the cloud startup, and they decided, among other things, no equipment on premises, everything in the cloud, and economy, you know, their eye on the whole margins of everything, and they decided to use standard edition. They also decided that to design from the get-go to use EBR, and you know, there was no specific adoption step. They were just using EBR from the very beginning in their concept. And they just programmed all this stuff using the DDL lock timeout idea, knowing that their periods of pending DML would be short, knowing that it wouldn't be an ultimate problem, and therefore perfectly okay. Okay? So these things are just extra stuff that you'd have to think of when you'd prefer not to have to think about it, but not ultimately showstoppers. And in that connection, and having set the stage carefully that way, I just have to tell you some slightly annoying bad news, and that is that if the database in which you want to do EBR and take advantage, therefore, of non-blocking DDLs happens to be a source for Golden Gate, which then will do redo mining and replay somewhere else, or it doesn't have to be Golden Gate, anything, including logical standby too, where your database is the source of redo that will be mined elsewhere. If that's the case, you have to do some magic step called enabling supplemental logging. And when supplemental logging is enabled, whatever on earth it might mean, it's like you have to turn on the blue fan. And if you've turned on the blue fan, which you have to do, because the rule book says if you're going to use Golden Gate, you've got to have the blue fan running, then all these non-blocking DDLs silently degrade and become blocking DDLs. It's just a real pain. But the engineering challenge to fix that is so huge that I don't know when it will be fixed. So for the time being, it's just something you have to contend with. The bad news is, oh dear, it's something you have to understand and contend with. And you know, you find yourself talking about blue fans all the time when you wish you would have more time for more interesting things. But the good news is it's not as if it's the end of the world. You just have to follow a certain programming style. And as long as you don't have long outstanding pending DMLs, it'll be no practical problem. Still with me? So that was rather a lot of explanation against a set of absolutely empty colored squares to get to this point here. So when people say, can I have the slides? Can I have the slides? I sometimes think that the slides won't tell you much without me talking. Right then, we're here. So the point was, magically, we got those columns that we need in place, even though there's never a moment without pending DML. Not only that, but for reasons I think you well understand, given that fine-grained dependency tracking came in 11.1, and we've already talked about it a few times, you get what you want without invalidating the covering editioning view. And since nothing else touches the table, everything else is standing on the top of the editioning view, ergo, the whole shooting match remains valid. So that's good. Of course, you had to have that, but you do have it. So everything is good. So now we've got this far. It's obvious what we do next. We want the new world to see two separate columns. At the moment, it's not yet seeing what we want it to see. You have to redefine the employee's editioning view so that it selects, as you see from the arrows here, the two new columns and no longer selects the old one. So the editioning view in the old world selects all the columns and the old style phone, and this one selects all the columns and the new style pair while not selecting the old one. That, I hope now, is crystal clear in pictures, if not all the words I used before made it clear. Yes? Is that crystal clear? The illusion in the world of the application code is that that table just mysteriously and magically lost a column and gained 2 that you want. Under the covers, both the old and the new are simultaneously present, while all the unchanged ones are just there, untouched. The old, unchanged ones that are common in both need no synchronization because they're the same in both worlds. The only synchronization needed is between the old single one and the new double pair. It is needed in both directions. And the space picture is sparse, isn't it? We've just done our hand-oriented sparse copy. And it's especially sparse if you think of all the other tables that a typical application have that are not involved in any kind of changing in this application. They just sit there, same in the old world, same in the new world, self-synchronizing, which is reinforcement of the notion that this technology has to operate in a single database to be viable. Okay then. I believe I've said everything of interest there. There was something on the tip of my tongue. Where are we now? The next thing we need to do is consider the synchronization. So, sure enough, we'll put the synchronization mechanism in place, the forward cross-addition trigger. And if it wasn't crystal clear before, I hope it's completely crystal clear now in pictures. Yes, as I bring it in and take it away, you can see that the forward cross-addition trigger has the purpose of noticing when changes take place here, in this column, computing from the changed value, the new 2 derived values in the new representation. Yes, that's its purpose, going forward from the old to the new. Now, what do we next think? That the column pair that we want are in place, but the values that should be in them are not in place. There's something missing. What we want is that that transformation that we've programmed in the trigger is forced through, you force the pace so that it happens in every row so that the column gets populated, yes? Yes? Now there's a simple way to achieve that, which is bound to be correct, and that's you do a very naive update on the table. Update table, well, it's not even spelt that way. Update employees set pk equal pk, right? I don't know if you've realized it, but though that has no effect on the stored data, it does fire the trigger. So that way you'll fire the trigger on every single row, and you'll do the transformation, and you'll get the result you want, okay? When I say that, some people start to panic, particularly in Finland yesterday, actually. There was a massive panic. I don't know why. Triggers are bad. Whoa. But I think I calmed them down by pointing out that it's not all tables that have this, and anyway, that existence-proof empirical outcome with eBusiness Week customers, they haven't complained about this, so however bad it is, it can't be that bad that anyone notices it. Anyway, yes?
So what if you have a lot of other triggers on that table? Maybe typically those that creates historical
Yes.
values and stuff.
Well, they won't be on the table, they'll be on the additioning view, but what if you do? Well, you do, they're just there, and they do what they're ordinarily doing. All that will mean is that the fractional impact that one more trigger has, when you before had n and now have n plus 1, is less than if you had 0 and you go to 1.
Okay, but you said that the cross-additional triggers, they always run on the table, but
yes.
Maybe the triggers you had beforehand, you move them up to
yes.
working on the additionable.
Additioning view is the word, yes. Yes, that's correct. I wonder what your feeling of unease comes from, because I don't feel any unease about that.
Order, I guess.
I
was thinking more than you created the triggers in the first place.
Yes.
To achieve something. Maybe you made an update on the table, or you want to put something in.
Well, let's think about it this way. Think about it very carefully now. And I may not have yet taken you through this by hand, so this is the first time I'm doing it. In the new regime, the EBR ready regime, 2 things are true. One, the insert, update, and delete that's happening all the time by virtue of ordinary end-user application activity coming through all the code of the app is coming through the additioning views, right? It never goes direct on the table. And when you have a trigger on an editioning view, and when that trigger is also editioned, then it's the occurrence of the trigger in the edition that's now current when you do that that fires. And it will fire because the DML came through the editioning view. Now, that would also fire triggers on the underlying table. But the converse is not true. If you have a trigger on the table and you by hand do DML directly on the table, it'll fire only the triggers on the table, but it won't pop up and fire the triggers on the editioning view. And in the case I just described, you have the trigger in place so that when end user activity comes in through the editioning view and fires whatever triggers it needs to fire there, it will also hit the table and fire the forward cross-edition trigger on the table. On the other hand, if to force the pace, you do your SQL transformation at the table level to copy from the from the single column to the pair replacement columns, then the triggers above you on the editioning view will not fire. Now, I don't know what you were worried about in that picture, but anyway, that is the picture of what happens, and it works fine. There are no runtime problems that you may think you're seeing. I can promise you it all works out fine.
Yeah, but you said earlier also that some of these triggers you should consider if they the ones you had before you started this EBR thing.
Yeah.
If you should consider if you should put them on the table or on the edition.
Yes, that's true. So it's true that then when you update the table and set it thing to itself, you would be firing a couple more triggers than you otherwise would want to. Yes. Unless those triggers were carefully written with a when clause so that they fired only in response to things in some columns, in which case they wouldn't fire after all. Yes? I expect you know that when you have a when clause in the definition of a trigger, then the SQL side of the world works out if it's even going to hop into the PL SQL world and run the trigger or not. And if only some columns are affected, none of which are mentioned in the when clause, then the trigger's not involved at all. But ultimately, it is what it is. And there's another, you were clearly thinking of performance there, because if you update a table and set one column equal to itself, the only thing that the trigger can do is write values in place that already are there, right? So the only thing you could be worried about was performance. And I tried in the end to put it this way to the doubting Finns yesterday. And that's, you have a stark choice. And I think I've made this as vividly clear to you as is possible. The choice is, choice is in the face of what you want. You want to upgrade your application, seriously, semantically. Or even you want just to patch your application. I hope I've convinced you that you cannot safely do it in sort of hot patching style. All you can do is either take downtime and do it and come up again, or use EBR. Those are the only choices. So let's assume you simply refuse to take downtime because during downtime the performance characteristics are rather poor. You know, in the e-business suite, the response time for any end user activity was a few hours or a few days, right? That's poor performance by anyone's standard. So if you don't want that and you use EBR, and if during the duration of the exercise performance is slowed down a bit with respect to normal, that's still better than taking downtime, isn't it? And that's really the only choices you've got, you know. Your car's broken down, it's in a bad place, you can't leave it there. All you can do is push it out of the way. And though you're pushing out of the way by hand and it's going much slower than if you were driving it, it's still a better option than not. Yes, sometimes you just have to think of things that way. You want the goal very badly, and there's one way of getting it, and it is what it is. I hope that puts your mind to rest to some extent at least. Now then, let me just show you that. That's meant to symbolize updating the whole table, firing the trigger on every row, and producing the semantic effect that you wanted. Some people, not least Graham Wood and Tom Kite in his day, insisted that a priori, that can't be good, because triggers blah, 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 you should just use a proper SQL statement to do it. Well, if you want to do that, be my guest. And later I'll talk about some subtlety in what you have to do to make it happen right. But you certainly can within our paradigm, and it still all works out right. But I think you should inform yourself always by this higher level way of seeing the world. When you do downtime patching, then you're doing patching. That's the only thing you're doing. And while you're doing it, the system is down, and everyone hates this, and they're all stressing you and watching you, and come on, you're finished, come on, finish, this is terrible, it's awful, finish, work faster. So your aim in downtime patching is to get the whole thing done as quick as possible. But your aim in zero downtime patching using EBR is different. It's not that at all. It's to have minimum impact on the ordinary end user community. So you can throttle back the pace of your EBR exercise exactly so that it steals less noticeably the resources from the end users, and just bide your time. Because the worst that happens is that the end users get that new functionality a bit later than they otherwise would, but they're never cut off. So that's a different way of thinking about it. Now, in this example, we do have to pay attention to the end user experience, those people who are not participating in the endeavor here and who are ideally not knowing it's going on. Suppose the table is humongous, you know, hundreds of millions of rows, then a single update firing the trigger on every row will take some noticeable time. And during that time, as the front of change moves through the table, then the chances are that any random change that an end user wants to make will be upon a row that's already locked. And that would be a bad thing if the user wanted to change a row and it was just waiting until that quite long-running single SQL statement is finished. But then the solution to that one is trivial, mind-blowingly simple. You don't do the thing that way. You just divide the table up into chunks. How big are the chunks? They're as big as they can be, but no bigger than that. The time taken to process a single chunk is still so short that it never takes such a long time that the end users notice. You know, you could pick a number. If we're bluffing away that any delay up to 10 seconds is the network in the hotel, so to speak, then we can just pick 10 seconds. Yes, your question?
But still then, there is a problem in the post version. So
yes, the new version,
that
yeah.
have connected there don't have the information in the new columns, because that view is picking the information from the new columns.
Well, I think you said it yourself. You said what the...
You need to prepare the columns before you're switching.
Yeah, you're saying that as if it's a problem. Actually, what you ought to be saying is that you need to get certain things in place before you open up the new world. And that's what I'm saying. You know, it's no more than that. So, thank you for pointing it out. So back to this chopping it up into slices business then. We have a package called DBMS Parallel Execute who lets you do that with a minimum fuss and bother. You just say, I want so many slices, chunks. It'll do that for you. Then process me chunks, please, and manage it all. And if I even interrupt you, keep some notes about how you're getting on so that you will know eventually when you've finished and you'll tell me when you've finished, okay? And it must be the case that the effect of these triggers is idempotent. You know what I mean? It'll have the same effect every time you do it. And therefore, it doesn't matter if you do a given row several times. Ideally, these chunks should be non-overlapping to avoid duplicated effort, but they must at least cover in union the whole table. And this DBMS Parallel Execute package ensures that. And the critical thing is, it doesn't matter what order things happen in it. You know, you might update a given row manually, I should say as a consequence of random manual activity, before the bulk application of the thing gets to it. It might be the other way around, but because of this idempotency and the way triggers look after contention in that space, things will work out right. With me so far? Okay. There's a critical point here, though, and I'll tell it you now in sentences so that when we see the code, which might look a bit complicated, you'll know what the semantic challenge that the code is implementing is. And it's one of these insidious race conditions as well. So do this thought experiment with me. It's again the old two-table SQL plus thing you can do yourself, and you could do it yourself just for sport, and then you'd see the effect. Suppose that you have a two-column table. You don't need any EBR just to demonstrate this. Two-column table, C1 and C2. And you have in mind a trigger who's going to update C2 to C1. In other words, the logic will say colon new.c2 gets colon new.c1, right? Simple as that. And you populate the C1 with a load of values, and you leave C2 totally empty. Now, this is the thought experiment. 2 sessions again. In the first session, you do, for example, update, there's a primary key, update T, set C1 equals C1, it's a text column, concatenated with dog, where PK equals 42, right? You just do that, and you don't commit. You have a trigger in mind, but it's not there yet. Now, in the other session, you create the trigger, and you run it on every row. You then say update T, set PK equal PK. And the trigger fires on every row, and then you look in C2, and sure enough, there's a value in C2 for every row. The value in C2 for PK42 is the value that obtained before that guy did his change, right? So it's a stale value. The idea is that that guy's change be reflected by the code in the trigger, right? But now what happened is, in this scenario, what happened is that the guy did his update, and it's been and gone. How is the update executed? It's executed by virtue of first having compiled the SQL statement. At SQL compilation time, once the name resolution has been done, and a particular table has been discovered, then the whole system, the compiler, says, are there any triggers on this table that I have to, is he at it again? It is too. Are there any triggers on this table that I have to account for? If so, build in the logic to fire them into my plan, yes? But this particular update has taken place in the absence of such. I need a laser here. Now you see the race condition, right? That would be unsafe, and it's insidiously unsafe, because if you've not done that thought experiment, you perhaps wouldn't even be expecting the possibility. So you would just naively create the trigger and enable it, fire it on every rose, and think you're okay. And that's like catching bad data off a toilet seat. You kind of, oh God, I don't know, did I get bad data or not? Oh, some didn't, oh gosh, you just don't know where you stand. Don't do it, right? Is a simple thing. So you have to follow a careful sequence. You have to create the trigger. By the way, now I have to say something there too. I've told you so enthusiastically, so carefully, so compellingly, that no DDL in the presence of continuously ongoing DML is safe. Now I'm telling create a trigger in the presence of continuously ongoing DDLs. We had to make sure that that one was safe by paying explicit attention to that. And the way you do it is you create the trigger disabled. If you didn't realize that, new in 11.2, it's possible to create a trigger disabled, and only then do you enable it. And that's all part of the recipe of making sure you don't get those mysterious 4068s out of the blue, given that whole thing I told you about Oracle and its stockholders and OLTP and high performance. But that's okay. You just do that and you're okay. Then you call a PL SQL procedure that we've provided called wait on pending DML, and it will patiently wait until every outstanding DML to the table in question over all the concurrent sessions you have at the moment that obtained at the moment you made the call have finalized, either by rolling back or committing. And once that procedure comes back to you, now you know that it's safe to go through all the rows mechanically, okay? So once you know that that's the case and that's the procedure, it's simple. Otherwise, bad data off a toilet seat, which you don't want. So now we're almost there. We're but we're not ready to open up the new world yet, because at the moment, the reverse cross-addition trigger is not in place. So we put it there, okay? Now this is it. This is exactly the moment just before hot rollover begins, and this is your opportunity for doing what some people call the touch test. You can exercise no end of query functionality using the new edition in your secret session and see that you like it. But I think you can see that you can't experimentally try new functionality for DML for changing, because its effects will propagate back into the old world. You just have to rely on the fact that you tested it all so carefully in development, and now you're giving it your best shot, and you believe it's going to be faultless, okay? So now hot rollover can begin. And hot rollover begins, as you remember, by throwing the switch in the traffic director. In the general case, if this were one of those little no semantics entirely inside the database done in secretly and flip them over things, you would just update that value in that one row, one column table that I described, and they'd flip themselves over. But sure enough, you'd have their tiny little short duration hot rollover. Here it's a longer duration hot rollover. That's what I mean. This is hot rollover, okay? The triggers are firing both directions, and it's all perfectly okay. Eventually, you notice that the population on the new part has subsided away. And then, as described before, get rid of the application server that you used to be using and put the old thing off limits, right? And now you can see that there's some stuff to pick away. But the first thing is that the cross-edition triggers that were there are no longer there. If you think about that, and we will do this in code in a minute, there's a little bit more to the story. Chances are that the old phone number column had a not null constraint on it, and I'm sure a unique constraint on it, because it was just one column for everyone in the world, and when you phone someone up, you want one result. So phone numbers are meant to be unique across the whole world, so there's been a unique not null constraint on that one column. What you now need is a not null constraint on each of the two new columns and a unique constraint across the pair of them, right? So they've got to be put there in a certain order, and then don't forget that each time you insert a new row in the new world, the cross-addition trigger, the reverse cross-addition trigger, will fire and populate the otherwise empty column in the old world. So if you suddenly just took away the forward cross-addition trigger without thinking about the constraints, your running app would immediately start to show errors. So you've got to do this in the right sequence. Take away the not null constraint first, take away the unique constraint, and then you can take away the reverse cross-addition trigger. And all these little steps need close attention paid to the way you spell them to make sure they're all non-blocking DDLs. But what do we notice now? We notice that this guy has been redefined there. And the definition that we have in the various rows in the data dictionary that represent this guy, that's entirely a waste of space, right? Same with this. And we call these guys, I call them at least, covered editioned objects. Covered because the definition there is now invisible because the new definition here covers it up, yes? So those covered editioned objects are just a waste of space. We know what they are because we contrived their being covered by explicit steps in our exercise, so we can simply drop them, right? And to drop them, following our paradigm, which is always stay sitting in the new edition in the EBR exercise script, that's where we need to reach into the old edition, bounce into it with a trampoline, and come back. You might think, why don't I just alter session, set edition, the old one, and drop them and come back again? I can't convince you that that wouldn't work. Indeed, it would work. It's just not the right, it doesn't feel nice. You just want to be in the new edition, be safe. It's loosely speaking, just a loose analogy. It's like if you had to convince someone who knew the sys password that it was a bad thing always to log on as sys for anything they might do, You just want to protect yourself against slips, so you give yourself a kind of minimum privilege regime all the time. And so it is very loosely speaking, analogously with this edition stuff. Switch into the new edition, because that way you don't run the risk of doing anything by mistake that would impact the running system. And even this dropping the objects, reach into the old edition from the new edition using the trampoline, just because it's the paradigm. Okay, so now there they are gone. And what we notice here is that that column over here is colored gray, meaning that no one can see it any longer. There are no surviving editioning views who project that column. So it's in a sense garbage. You could, if you think it's a nice idea, set it unused. That DDL is a non-blocking DDL. That would give you a more tangible flag on it that it's gone, but you can always compute it's gone by looking at the editioning views. Anyway, it's just a candidate for some time lazily garbage collecting it later on with, let's say, DBMS redefinition. Okay? I may as well just say it now. I could have said it ages ago. Why do we call it edition-based redefinition? It's obvious now. DDL stands for data definition language. Create, blah, 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 that's definition. Create or replace, blah, 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 or alter, blah, 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 it's redefinition. When you just do it like that, bang there, it's just in-place redefinition. When you use online table redefinition, there's the word, it's been around for a long time, you're redefining a single object using kind of secret copy scheme for that one object behind the scenes. And it's the same with some index rebuild things. Now we're redefining a whole slew of objects in concert using the mechanism of the addition. Therefore, of course, it's called edition-based redefinition. So it's not a kind of randomly selected name, it's just a name that springs out for itself as the only name we could have, EBR for short. So if I have time, I'll say a few words about the proposition of online table redefinition at all, but for the time being, let's assume that just at some time, at your leisure later, you can simply spring clean away that column, okay? Well then, we've finished now. And what do you notice? You notice that the number of actual objects that we have is no different from what it would have been had we done all this without EBR in downtime. And that's an interesting invariant to hang on to. Imagine this was a much bigger system with all, 1,000 editioned objects, and that you'd done lots and lots of EBR exercises, and after each one, you'd religiously got rid of all covered objects. Then you would still be in that state. You'd still be maintaining the invariant that the number of actual objects, these guys that you have, though if you look at the whole picture, some of them are actual in the base edition, the root, some of them are actual in the next, some in the next, some in the next, representing the history of what you've done, there would still be no more actual objects than there would have been in a flat world. The only difference between this and a flat world is that exactly the objects are spread among a load of editions, and you've got more editions than you otherwise would have had. But the metadata needed to represent an edition is tiny. It's basically a row in obj dollar and another row in, guess what, edition dollar. It's a tiny little thing. So I'm trying to say that there's no penalty for having a tail of hundreds of retired editions behind you, as long as you've made sure that you've got rid of all covered objects, because then your invariant is held that you have no more actual objects than you would have had in a flat world. You've got exactly and only what you need. Still with me? I'm saying it that way because almost everyone who hears about EBR starts to panic at the idea of having all these old editions, and they must know how they get rid of them. They just got to get rid of them because you have to. And as long as I give this little speech up front, I hope I can make you feel comfortable about the idea. It's perfectly all right to have hundreds of editions going back because they're such lightweight things. And when you've done your spring cleaning, fine. But do your spring cleaning. Now that brings us to 12.2. Here, in my example, I just very much knew what I'd done, and I explicitly dropped the two objects I didn't need any longer. I've talked to some customers who never thought of doing that, and they've ended up with thousands of junk covered objects. I'm sure you can see that it's not that hard to discover them entirely programmatically, not knowing the history, just by some suitable query that looks across all the editions and does stuff, yes. In case you were wondering, there's a special view called DBA objects AE that shows you results that's insensitive to the present current edition. You just see the whole story across the database. You can use that with some suitable connect by prior sort of stuff to discover the covered objects, and then you can simply delete them by mechanically constructed SQL statements that you execute dynamically. I've written such a procedure. It's not hard to write. There isn't such a thing as part of the product. We were talking of doing it, but then we realized we could do something so much better. So now I'm going to tell you how things are in this space in 12.2. It's this, but it's against a background, so I'll tell you the background first. Up to and including 12.1, this idea that the edition that used to be the leaf, the former run edition, and that's now the parent of the leaf, is retired, and indeed you've taken stuff out of it, so it's no longer viable. That is entirely in your mind, so to speak. It's in external document, external doc. The strongest thing you can do to represent that in the database is just set the default edition to the new leaf, but that's just a little tiny symbolic thing, and revoke the use privilege from every user in the database, including nominally from sys, but it makes no difference whether you've granted a privilege to sys or not. Sys is unstoppable. So kind of the sad, disturbing fact is, up to and including 12.1, there isn't a really reliable, robust, formal way. There's no DDL that implements retire edition. All there is your self-imposed paradigm. As long as that edition has no privilege except unstoppably sys can do stuff in it, but no explicit privilege, it's retired, okay? But someone who didn't like that could always go back and start granting privileges at all. And for that reason, we couldn't allow ourselves in the implementation of Oracle to do any automatic garbage collection. So therefore, we redefined the meaning of drop edition in 12.2 as follows. First of all, I should tell you the rules for drop edition, which I should have perhaps had on one of the slides, but now is a good time to mention it. First of all, drop edition is never ever allowed on any intermediate editions. If an edition is in the middle of the string, you can't. In other words, the only candidates for drop at all are the leaf and the root. Now, drop edition is always legal without any restriction on the leaf, and nothing has changed about that story in 12.2. If there are actual objects in it, same as if a user you want to drop owns objects, you have to use the word cascade, but if you use the word cascade, you get the effect you get. All the objects are really, really, really taken away, taking the really, really time it takes to do it, and then the leaf is gone, and the parent of the leaf is the new exposed edition, okay? Incidentally, that would be another thing that we couldn't stop you doing, crazily, through 12.1. You could just drop the leaf when you thought you'd retired everything else, which would mean in some kind of conceptual sense, you had ended up with no editions in the database because all the other ones are complete junk. And we said one of our axioms is you can't have no editions. So it's a kind of very unsatisfactory feeling. Now, the other candidate for dropping is the root. Now, through 12.1, it was just absolutely straightforward and brutal. If the root contained at least one actual object that was inherited in its child, of course, it would have to be inherited in its child if it was inherited even further along, then drop edition simply fails immediately with an error message expressing that fact, okay? And therefore, you could never drop editions in 12.1 and indicate that they were no longer part of the picture, except that you emptied them explicitly. The magic of 12.2 is that we simply reimagined it so that drop edition is always legal on the root, even if it's got a ton of objects that are inherited up the chain. And all it means is it's a metadata-only operation, so it's instantaneous. A flag is set that says this edition is semantically dropped. Okay, we spell it unusable, and there's a column in DBA editions called that. And when it's unusable, in this 12.2 definition of the world, then not even a session authorized as sysdba can use that addition. So it really, really, really is gone. And then if all additions but the leaf have been dropped in that semantic way, even though they're full of objects that are important because they're the actual home of the objects that are inherited in the leaf, then you can't drop the leaf because semantically the leaf is the only addition that's there, and then our rule holds. So that's a good thing. In 12.2, we've got a very tangible DDL that implements retiring the previous addition. And then therefore in 12.2, your overall higher level paradigm of operation is crystal clear. In normal life, you've only got one addition semantically present, and it's the physical leaf in a chain of history going back behind you, but the history of stuff behind you is semantically inaccessible. It's just participating in producing the semantic effect that your whole world is as you want it in the leaf, right? Then exciting life, well, mildly interesting life, I should say, EBR exercise ongoing, but nobody worrying about it. Then you've got two additions you care about, two additions that have not been dropped. You've got the run addition and the patch addition. And when you reach the end, the patch addition is promoted to become the run addition, and you drop the former run addition, and you're back to just one addition. So it's so crystal clear, so clean, so nice. And the other thing is, now that we really, really, really have such a strong definition of dropped, namely not even sys can get there, we can allow a magic background program to wake up periodically, snoop around, find the covered objects and take them away in a kind of opportunistic way. Maybe to take a few cycles of waking up, it depends what you did, but they'll just go away of their own accord in the background. You don't have to even think about it. And moreover, if you ever arrived at a state that the root happened to be totally empty because the objects it used to have in it were discovered to be now covered and they went away, then the whole root addition would be taken away too. And if you think about it, if you wanted to force the pace, at any moment in the next EBR exercise, you could conduct it as you plan, and as the final step, discover from the data dictionary any additioned objects that are not yet actual. All you need to do is go alter, if it's a view, alter view v compile. If it's a procedure, alter procedure p compile, reuse settings. That's guaranteed to actualize the object too. So you can arrange, if you want, to finish an EBR exercise with no objects in the leaf edition except actual ones. That means every other object in the database is a covered object, and that means when you've dropped the parent of your now new leaf, the daemon in the background will empty the whole shooting match away, and then the additions themselves will go away, and you really, really, really will have just one addition in the database, all automagically behind the scenes. So for reasons like that, for anyone who's not yet using EBR and who's going to adopt it, I strongly, strongly, strongly encourage you to bite the bullet and go to 12.2 to avoid thinking about this stuff, to get that simple, clear model. I'm just going to do my very utmost to encourage you, if you're not yet using EBR and if you want to use it, to go to 12.2 because of the complete, simple elegance of the whole thing. Right then, that's that whole point there. I don't need to speak to that slide because I did it just out of my head.